Hi and good day. Today we'll be talking about some grade 10 mathematics. Course code is MPM2D, and the topic at hand today is factorization. Now, factorization is an indispensable tool for any mathematician. You'll see this throughout your high school careers, you'll even see it at the university level as well. And it's very important because it helps to simplify problems and it helps to easily solve them as well. Common examples are with maxima minima problem in differential equations, finding the roots of polynomials, and the list goes on. So before we delve into the actual material of factorization, we just need to have some recap. So firstly, we need to understand the product between negative and positive numbers. So if two positive numbers are multiplied by each other, you also get a positive number. If a positive number is multiplied by a negative number, you get a negative number. Similarly, if a negative number is multiplied by a positive number, you again get a negative number. And the final rule here is that if a negative number is multiplied by another negative number, then the result is positive. The second bit of recap comes under the exponential rules. So there are a good bit of them, and it's important that you memorize these. So the first one is that, say you have some number, we'll call it x, and y for this slide. And if you have x raised to the power of a, and you multiply it by x raised to the power of b, then that is equal to x to the power of a plus b. Similarly, if you have x raised to the power of a and it is divided by x raised to the power of b, that is equal to x to the power of a minus b. Whenever you're dividing though, one quick thing, x or your denominator cannot be 0. This is what you call an undefined solution or undefined problem. The third one here is that if you have x to the power of a and then you raise that thing to the power of b, then you get x to the power of a times b. And the rest are pretty straightforward as they are extensions from the first three. You have x to the power of negative a, which is just equal to 1 over x to the power of a. X to the 0 is 1, x to the power of 1 is x. And then if you have a product that is raised to some power, then the power is applied to each individual element in this product. So xy to the power of m is equal to x to the power of m, y to the power of m. And then if you have x divided by y, all raised to the power n, then that is just simply equal to x to the power of n divided by y to the power of n. Again, we're dividing here, so our y cannot be 0 in this situation. So now let's go into the definitions. What you need to know before we start delving into factorization. First thing is a factor. So a factor is a number or an algebraic expression that divides another number or expression evenly. That is, when you divide them, there are no remainders, there are no decimal points, there are no fractional values. You get a nice flush whole number. So for example, 24, the factors of the number 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So if I were to divide 24 by any one of its factors, I will get a whole number. For example, 24 divided by 4 is 6. 24 divided by 12 is 2. Similarly, we can have an algebraic expression. Here we have x to the power of 3 y squared. And that is equal to a bunch of factors as you can see on the screen. So if you divide x cubed y squared by any one of those things on your right hand side, then you again get a nice flush algebraic expression. The second thing you need to know is what is called the greatest common factor. This is defined as the greatest factor that divides two or more numbers, or expressions even. So for example, let's consider the numbers 4 and 12. From the previous slide, the factors of 4 are 1, 2, and 4. The factors of 12 are 1, 2, 3, 4, 6, and 12. So these two numbers, 4 and 12, share factors 1, 2, and 4. Thus, the GCF, or the greatest common factor between 4 and 12, has to be the largest shared factor, which in this case is 4. Similarly, what is the greatest common factor between 30 and 45? The shared factors are 1, 3, 5, and 15, so the greatest common factor, or the greatest shared factor, is 15. So now we go into factorization, and then we will extend this theory of factorization into quadratic factorization. How do we factorize quadratics? So the first step in the procedure is to determine the GCF of all the terms involved. The second step is to take that GCF out to the front of the expression. Then we apply brackets to the original expression. So that excludes the GCF we have just taken out. And then finally, we divide all our terms that we have bracketed by the GCF. So let's consider the following scenarios. We have 4x plus 2. So in terms of numbers, we have 4 and 2. So then our GCF has to be 2. 2 can be divided by 2. 4 can be divided by 2. We have a variable x. Now there's a 4x plus 2. So x is not shared by both these numbers. So what we can do, we can take out 2 as we look at the middle equation. So 4x plus 2 is equal to 2. That's our GCF. And in brackets, we have 4x plus 2, each divided by our GCF, which is 2. And then finally, that is equal to 2. And in brackets, we have 2x plus 1. This is where our exponential rules come into play. And we'll see that in the next example. 8x squared plus 15x. 8 and 15 share only one common factor, and that's the number 1. So we can take 1 out, but it's understood 1, if it's there, it's not there, it exists. However, 8x squared plus 15x shares an x. So 1x, or just simply x, is our GCF. So we take our x out, we put 8x squared plus 15x all divided by x in brackets. We divide by x because it is our GCF. And then we divide again using our exponential rules. So we get x multiplied by 8x plus 15 all in brackets. If we watch our final example, 12x to the power 4 plus 8x squared minus 16x, our GCF is 4x. So we take 4x out, we divide 12x to the power 4 plus 8x squared minus 16x by 4x, we divide it by 4x, and then we get the result on the right hand side, which is 4x multiplied by 3x cubed plus 2x minus 4, all in brackets. So now into quadratic factorization, we will consider only integers in our quadratic. And what do I mean by that? I mean that if we consider the standard form of a quadratic, it can be written as ax squared plus bx plus c. So a, b, and c are all numbers, and by extension, there will be only integers or whole numbers for this lecture. So to solve a quadratic, firstly, we look for two numbers, we call them alpha and beta, such that if you multiply alpha and beta, you get the product of a and c from your original quadratic. And if you add alpha and beta, you get b, again from your original quadratic. Secondly, we expand bx as alpha x plus beta x. And then we have our new form of our quadratic equation, ax squared plus alpha x plus beta x plus c. And then we factorize the first two terms, and the second two terms, we will factorize a second time, and you get a nice simplified expression. So let's go straight into an example. Consider 9x squared plus 18x plus 5. So we look for two numbers, alpha and beta, such that alpha times beta is equal to 9 times 5. 9 is our a in our quadratic, 5 is our c. So 9 5s are 45. And alpha plus beta must be equal to 18. 18 is our b term in our quadratic. So let's look at the product one, alpha times beta, and let's start with the smallest factor of 45. We can look at 1, but let's look at 3. So you know that 3 times 15 is 45. Okay, that's nice. But now let's look at alpha plus beta. Does 3 plus 15 give me 18? Yes, it does. So that's really nice. So we move on now. We expand it now to 9x squared plus 3x plus 15x plus 5. Then we bracket the first two terms and the second pair of terms, and from that we can factorize. So if you look at 9x squared plus 3x, our GCF is 3x. 3x can divide both these terms. So I take 3x out and I divide 9x squared plus 3x each by 3x. And similarly, if I look at the second bracketed terms, 5 is my GCF. So I take 5 out and I divide 15x plus 5 by 5. This gives 3x, and in brackets 3x plus 1, plus 5 in brackets 3x plus 1. So what we notice here is that, hey, we can actually factorize again. So I can take 3x plus 1 out, bracket my original expression, divide by 3x plus 1, and then finally it simplifies into 3x plus 1 multiplied by 3x plus 5. So in conclusion, just to recap what we've done here, to factorize anything, you find your GCF, you take it out in front of your expression and you bracket your original expression, then you divide everything by your GCF. And then you rinse and repeat this procedure until you get the most simplified form possible. Thanks for watching, and I hope that we had a productive lesson.